Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Yet another new chapter, and this chapter again is the base of so many higher calculations. I hope you have seen the previous 75 videos in which I have taken up the basic operations of adding, subtracting, multiplying, dividing, squaring, cubing, square roots, cube roots, all these concepts, they are the base of everything. So hope you have watched everything, and if not, follow them in a sequence. And this is one of the very important topics, that is the writing of fractions in simplest form. So the basic thing here of understanding the common factors, cancelling out the common factors, I'll tell you how to do that. And this forms the chapter number 5 of our ebook of short tricks, which is the art of manipulating the fractions. That is the title of the chapter. So all these tricks, which I keep on posting on the YouTube channel, they are a part of this ebook of short tricks. And if you want a compilation of all these short tricks at one place, you need to spend a little bit on your education. And if you are willing to do that, then send me a message on WhatsApp. This is the WhatsApp number 9896369963, and all these details are contained in the description of this video below as well. So friends, what do you do when you have to write the fractions in simplest form? The first thing you need to understand are the factors. So you should know that every number can be expressed as a product of primes. Just like we have the number 12. 12 can be written as 2 times 2 times 3. Likewise, the number 20 can be written as 2 times 2 times 5. So every composite number can be expressed as a product of primes. And so when you write the factors, there may be a common factor between the numerator and denominator. I'll show you how. See, now suppose this is 27 upon 117, which is the fraction. Now I need to understand that both the numbers here are odd numbers, and whenever the numbers are odd, they will never be divisible by even numbers, right? So you have to check divisibility of the numerator and the denominator by odd numbers only. Likewise, if you have two even numbers here, they will surely go into 2. That means 2 will surely be a common factor, and that's what you need to do. Divide the numerator and denominator by the same factor, by the common factor. Now, if you are sure about the highest common factor between the numerator and denominator, the answer will be obtained in the first step only. But if you are not sure, go for the smallest factor. Just like 27 can be written as 3 times 9, and 117 can be written as again 7 plus 1 8 plus 1 9. So it is divisible by 3. So 3 times 3 3s are 9. 27 means 3 9s are 27. And now I know that there is a common factor 3 between the numerator and denominator. So I will cancel out the common factor 3. Rather than saying cancel out, I will say that 27 upon 117 will be divided by 3, both in the numerator and in the denominator. So you have to write this as the remaining factor 9 and this as the remaining factor 39. Now 9 and 39. Now we have to check whether 9 and 39 are co-prime or not. Do they go into some common number? 9 obviously is divisible by 3, right? But 39, can we check that? 9 plus 3 is 12, and 12 again goes into 3, and that means there is yet another common factor. So I found the common factor, but I did not find the highest common factor. That is why this fraction can be reduced further. So I have another 3 which I can take out. So I will divide this by 3 and this by 3, and this time 9 divided by 3 is 3 and 39 divided by 3 is 13, and therefore my answer for the question will be 3 upon 13. So 27 upon 117 can be reduced as 3 upon 13. Now why did I stop here? That is also very important. 3 and 13, they don't have any more common factors, or if you obtain prime numbers, like 3 is a prime number and 13 is a prime number, both are prime, they will not have any common factor except one. Even if one of them is prime, you just have to check whether, like here 3 is prime, so 3 doesn't divide 13, so automatically that is the simplest form. So I hope you have understood how to write it in simplest form, and now we can proceed little quickly. So 128 and 234. Obviously they are divisible by 2. So when I divide both of the numbers by 2, I will get 64 in the numerator and 117 in the denominator. And now I need to check by which number are these numbers 64 and 117 divisible. For that I will try to make factors. See, 64 is 2 times 2 times 2 times 2 times 2 times 2. So all 2's in 64. But 117 being an odd number will never contain the common factor 2. And that is why there cannot be any more common factors between 64 and 117. Because 64 contains only 2's and 2 doesn't divide 117. So even if you factorize, like 117 was here, so 3 into 39, so 3 into 3 into 13. Now there is no more common factor, and therefore 64 upon 117 is the simplest form of 128 over 234. Works like this is like, you know the concept and you get better. Let's have some more questions. Here you can see 39 and 156. Now 39, 3 plus 9 is 12, so divisible by 3. 156, 1 plus 5 plus 6 is 12 again, so divisible by 3. So I'll directly divide by 3. Why didn't I consider 2? Because 156 is an even number but 39 is an odd number. Odd numbers are never divisible by 2, and that is why I started with 3. So when you divide this by 3, you get 13, and when you divide 156 by 3, you get 52. And now comes the important part. So many of the students will feel like 13 upon 52 is the simplest form of this expression, this fraction. But it is not the case. See here, 13 is a prime number, right? And whenever you obtain a prime number either in numerator or denominator, you have to check the divisibility of composite number by the prime number 13, and you will find that 13 fours are 52, exactly divides 52. So 13 is a common factor between them. So when you divide by 13, you will have your final answer, because you will have 1 in the numerator and 52 divided by 13, 4 in the denominator, and this is the simplest form of 39 over 156. So can we do really quickly now? Both even numbers, divide by 2, divide by 2. So this fetches me a 42 in the numerator and a 63 in the denominator. 63, yes. And now 4 plus 2, 6, divisible by 3. 6 plus 3, 9, divisible by 3. So divide by 3, divide by 3. You get 14 and you get 21. And now 14 and 21, I hope that is pretty clear, divisible by 7. So divide by 7, divide by 7, you get 2 upon 3 as the final simplified form of 84 over 126. Likewise, I can go on and on. See, these are big numbers. So here we have 121 and 143. So we have to test by which numbers are they divisible. So when you check 121, the factors of 121 are 11 times 11. So it contains all 11s. So what do we have to check now? Whether your number 143 is divisible by 11 or not. And when you make factors of 143, you will find that it is 11 times 13. And so there is a common factor 11 between them. So when you divide this by 11 and the denominator by 11, you will get 11 in the numerator and 13 in the denominator, which is actually the simplified form of 121 over 143. And this, why is this the simplified form? Because 11 and 13 both are prime numbers. They are co-prime. They cannot be divisible by any number except 1. Now, the next question here, 248 and 762. Both are even numbers, and if both are even numbers, they are divisible by 2. So I will do one step and I'll leave the next step for you. Okay. So when you divide by 2, you get 124 in the numerator, and in the denominator it is 381. Now you need to tell me whether this can be simplified further or not. So I am leaving this as a DIY for you. You need to comment below whether 124 over 381 is the final answer, or is it divisible by some other number or not. Okay. So friends, I hope you have understood how to simplify these fractions. This forms the base of everything we are going to do in future videos, and if you like it, you need to hype the video. Once you click the like button, you will get the option of hyping. Give it some points so that it has more chances of reaching the audiences. Do subscribe to our channel and click the bell shaped icon. This is important to get the notifications on your mobiles itself. So practice a lot of such questions. It will form a very good base. All the best.